Next, let's look at another example that's slightly more difficult than the last one. In this case, we do have to rearrange our equations because the first one's written in standard form, but the second one is not. The second equation, in order for it to be written in standard form, the x term has to go to the other side of the equation, which we'll do by adding 3x to both sides to create an equivalent equation. So when we add 3x to both sides in the second equation, we'll end up with 3x plus 2y equals negative 13. And the top one's already in standard form, so I'm going to leave that one the same. So that's step one of the linear combination method, is to rewrite both equations in standard form. Step two, if you remember, is to multiply one or both of the equations by constants so that you end up with the same coefficients but one positive and one negative in front of one variable. It doesn't matter whether you choose the x's or the y's. For this one, the x's, the coefficients are 4 and 3. The least common multiple between 4 and 3 would be 12. So if I was going to go for the x's, I would want one to be a 12x and one to be a negative 12x. For the y's, my coefficients are 2 and 3, and the least common multiple is 6. So that's a little smaller. I think that's what I'm going to go for. So I want to make the y's, I want one of them to have a 6y and one to have a negative 6y. The top equation's already negative, so I'm going to make that one the negative 6y. It's currently a negative 3y. To make it into a negative 6y, I'm going to multiply by positive 2. So I'm going to multiply the top equation by negative 2, and then I'm going to rewrite that, come over here. So when I multiply the top equation by 2, 2 times 4x is 8x, and 2 times negative 3y is negative 6y, and 2 times 11 is 22. For the second equation, I have a 2y, and I want it to be a 6y. To accomplish that, I'd need to multiply that by 3. So I'm going to multiply both sides of the second equation by 3, and I'm going to write that over here as well. So 3 times 3x is 9x, 3 times 2y is 6y, and 3 times negative 13 is negative 39. Now I have the same number but one positive and one negative in front of the y's. At this point, this is where I'm supposed to add the 3 columns. So 8x plus 9x is 17x. Negative 6y plus 6y is 0. 22 plus negative 39 is negative 17. And you'll notice that the y's have been eliminated because of the way I set this up. 17x plus 0 is 17x. Divide both sides by 17, and I get x equals negative 1. I still need to figure out the y. I need to go back to one of the two original equations. I'm going to use the second one, although it doesn't really matter which one you pick. I'm going to take the second equation. I'm going to plug in a negative 1 for the x. So I've got 2y equals negative 3 times negative 1 minus 13. I'm going to simplify. And I get that y equals negative 5. So my solution is the ordered pair negative 1, 5. I'm going to erase some of my work here so that I can do a check. I didn't leave myself very much space to write. So I'm going to erase over here. I'm just going to go back to that original problem and plug in my answer to make sure I get a true statement. So 4 times negative 1 minus 3 times negative 5 equals 11. And that works out. And then for my second equation, plug in my solution as well. And I get a true statement, so I know that my solution is correct.